In this video, I'm going to go ahead and do some examples of factoring by grouping. The first example should look familiar because it's also an example we did in Guess and Check. And one of the reasons I wanted to do this example is because I kind of left it unfinished by mistake. Technically speaking, since I was only trying to demonstrate Guess and Check for factoring a trinomial into two binomials, there wasn't really anything wrong. But had that been a homework assignment, and the instructions said to factor completely, which is what we're going to do in 6.6, I believe, then if I had turned that in, I would have lost some points, because there's one thing you always do first whenever you do something like this, and that is you factor out the greatest common factor before you do anything else. Every term here has an even coefficient, so you can factor out a 2, and you would have 4x squared plus 7x plus 3. So then that means that we'd want to factor this. And you can kind of see that in the answer I gave. I had in the previous video, the answer was 2x plus 2, that's not a parentheses, times 4x plus 3. Well, you could factor out a 2 from this, and you'd have 2x plus 1 times 4x plus 3. But I only wanted to do that just to demonstrate something that you should be aware of. That is that whenever you're doing something on a quiz or a test, you definitely want to factor completely. I'm not going to go back and remake those videos because the point was made. But for now, I'm going to go ahead and do this as an example of factoring by grouping. So here's our first example. We want to factor this out. Let's put a little more space there. We want to factor, whoops, there's an extra parentheses we don't need, and I did something wrong. Okay, we want to factor this out. So the first thing we want to bear in mind is, factor by grouping, I should say. That's part of the instructions. Generally speaking, you'll have your option to whether you want to factor by grouping or by Guess and Check. And I would recommend Guess and Check because it's a little bit easier, but this is still handy to understand. So the first thing we want to do is we want to find what is AC. Well, AC, remember that A is 4, B is 7, and 3 is C. One thing that you will definitely need to be able to recognize immediately, I mean, you can write it down below if you want to, is A is equal to 4, B is equal to 7, C is equal to 3, but you definitely want to be able to recognize immediately what is A, what is B, and what is C without having to do that. Generally speaking, you'll be able to do that. I mean, there's nothing stopping you from writing down at the bottom for reference, A is this, B is this, and C is this. But it would be very beneficial to be able to recognize immediately that's A, that's B, that's C, just immediately. So A times C in this case is going to be 12, because you have 4 times 3 is 12. And then B is going to equal 7. So we want to find two numbers that when you multiply together make 12, and when you add make 7. Well, that's really not that hard at all. 4 and 3 look like they're going to be our culprits. I'll just put it off to the side here. 4 and 3, because they multiply together to make 7 and add to make, multiply together to make 12 and add to make 7. It's just a coincidence that it happens to be what's actually already there on the ends. But let's go ahead and figure this out. Let's go ahead and factor by grouping. So, whoops, let's make a new line there. Okay, so we'll have 4x squared, just the same as before, but now we want to separate this 7x into 4x and 3x. So I separated this 7x into 4x plus 3x. And now we can pretty easily actually see that we can factor out a 4x from here and a 3 from here. So this is equal to 4x x times x plus 1 for this first term, 4x times x plus 1. You can check that by distributing. 4x makes times x makes 4x squared. 4x times 1 equals 4x. Don't forget, once again, I said this before, when you pull out the 4x, there's an understood 1 right there. Okay, but now that that's out of the way, that'll really, really hurt you if you forget that. And then from this second term, we can pull out a 3 out of each of these, so we'll have 3x plus 1. So, from here we can kind of see that now we have an x plus 1 common to both of these. So, we can go ahead and pull out the x plus 1. So we'll have 4x plus 3 times x plus 1. And this is going to be our final answer. And we can check that, but we don't really need to. You know what, it's fast enough. We'll go ahead and check it. 4x plus 3. For the next two, I'm not going to check them, though, because we already did that in the previous videos. 4x plus 3 times x plus 1 equals 4x times x will give you 4x squared. 4x plus times 1 will give you plus 4x. 3 times x will give you 3x. 3 times 1 will give you plus 3. Notice something pretty important. We're just doing the exact reverse of what we did here. It doesn't hurt to do it because it's good to know that you did it right. And if you made the mistake here of forgetting to put the plus 1, this will demonstrate the mistake that you made. So, actually, you'll be completely lost if you forget to put the plus 1. So 4x squared plus 7x plus 3. You won't even get to an answer if you forget that plus 1. So 4x squared plus 7x plus 3. That is the answer, the problem we were given. So that means that this is probably the right answer. So we'll box it. This is the correct answer. Okay, so now let's go ahead and go to the next example. So factor by grouping, and this time we'll do 2x squared minus 9x minus 5. 2x squared minus 9x minus 5. Okay, so first thing we want to find out is what is a times c. A times c is going to be 2 times negative 5, so it'll be negative 10. What is b? B is negative 9. So, now we need to find two numbers that when you multiply them together make negative 10, and when you add them make negative 9. So, I can kind of see, and hopefully you can too, but if not, then, well, that's that. That'll be negative 10 and positive 1. So, negative 10 and positive 1. I feel like something's not quite right with this, though. Well, we'll figure it out if there is anything wrong with it. So, no, I don't think. I'm pretty sure that's right. Okay, so negative 10 and positive 1. So, because when you multiply them together, that'll get you negative 10. You add them together, that'll get you negative 9. So, negative 10 and positive 1 are the numbers that we're going to be working with. So, let's go ahead and do 2x squared minus 10x plus x minus 5. Now this one would have been trickier if we had just tried to guess over and over and over again to figure out what on earth are the two things going to be if we didn't know this method, because what ended up being strange, what we didn't really expect, is we had this number go higher. Instead of 9, it's 10. That's kind of not something that you would expect. You would probably be trying to do -5 and then -4 and just going all different ways trying to figure out how to make these two things work. But since we know this method, we can see pretty easily that it's going to be 10x and then positive x. So negative 10x and plus x. Okay, so now let's go ahead and go to the next part. And we can factor out a 2x from this part right here. So we'll have 2x times x minus 5. 2x times x minus 5. I just factored out the 2x, and you can double check that by multiplying distributing this 2x to the two things. 2x times x will give you 2x squared. 2x minus 5 will give you minus 10x. Okay, and from here you actually cannot factor out anything at all, but what we can do is we can just go ahead and write it out like that. So I'll go ahead and write it in parentheses like this. Okay, so remember, always remember, when you're factoring out a common factor, there's an understood 1, because otherwise this will be very confusing. You don't want to leave off the understood 1. I think that's the second time in this video that I've mentioned that, at least. So that means that you can change this to, you can factor out the x minus 5 to get 2x plus 1 times x minus 5. So we can double check this answer, see if it works out. 2x plus 1. I said I wouldn't double check them, but I just realized these are not the same examples we had in the previous video. It was just that one that was the same. So I'll go ahead and do it. 2x plus 1. So 2x times x will give you 2x squared. And then 2x minus 5 times minus 5 will give you minus 10x squared. And then plus x minus 5. And notice something that this looks pretty familiar. It's this. 2x squared minus 10x plus x minus 5. So that's kind of a good sign. That means we're on the right track. So 2x squared minus 9x minus 5. And that is the problem we were given. So then we know that this is probably the right answer. Alright. That is the end of example 2. We have one more example to do. So let's do this next one. Factor by grouping. 21x squared minus 13x plus 2. 21x squared minus 13 plus 2. So, first thing we want to find is what is AC. AC is equal to, well, what is 2 times 21? That'll be 42. And then B is equal to 13. This is going to be kind of a tough one, I think. Actually, no, that's not going to be that tough at all. What two things add together to make 42 and negative 13? I think I said add for this. Multiply together to make positive 42 and add to make negative 13. Well, that'll be negative 7 and, that's a strange looking ampersand, and negative 6. Multiply these two things together, you'll get positive 42. A negative and a negative makes a positive. Add them together, you'll get negative 13. Alright, so now we can go ahead and factor by grouping, because we know what the two things are going to be. There's probably a word for those, I don't know what they are. So 21x squared. So I'm going to separate this negative 13 into minus 7x minus 6x. Minus 7x minus 6x, and you can double check that by subtracting 6 from negative 7. You'll get negative 13 plus 2. So now I can go ahead and do 21x squared, blah blah blah. I can put these parentheses here, and I think, what can I factor out of here? Well, I can factor out a 7x. And then I will have left over 3x minus 1. Once again, don't forget the minus 1. Just because you factor out the 7 doesn't mean that there's nothing left here. It's still a 1. And for this one, we can factor out a 2. So we'll have... but there's something pretty important for this. I'm glad I caught this before we got any further. Let's go ahead and see what I did right here. That's not right. I can't do that. I can't just put parentheses around there like that. Before I do that, I need to distribute the negative. So I'll have make this a plus, minus, minus, like that. So now I can pull out a negative 2. What did I just do here? Does that... I mixed something up. Yes. Excuse me, I just did that wrong again. So, I need to make this... plus, minus, like this. Okay. My apologies. This is going to be kind of a funky problem. I'm glad we came to something this strange this early on, because this is a little bit awkward. I didn't really know. I'm going to write this out on the same line in the parentheses, just because I want to go ahead and see it the way I'm doing it right now. So, negative 6x plus 2. Okay, so let's clear this stuff off. Okay, so I'm going to go ahead and the reason why I did this way is because you can't just put parentheses around there like that. I'm very glad I caught that before I went too far. Now I'm going to go ahead and factor out a negative 1 because I want to get this in the right order. So that way I'll make this... I'll go ahead and change this to make this a negative. So I want to make this a negative, and that will make this into a positive and this into a negative. So it'll look something like this. Oh shoot, I didn't mean to get rid of all that. Well, it doesn't matter. So at any rate, 21x squared minus 7x minus 6x minus 2. So now I can factor out a 2 from this. But I'll still have a negative right here. So we'll still have a minus after this. So 2 and then 3x minus 1. Okay. That might have seemed strange. So if that is at all confusing, you might want to go back and watch that part again, because what I did here was I pulled out a negative 1, and that made everything inside of it into the opposite sign. So instead of being a negative 6x, it's a positive 6x. So instead of being a positive 2, it's a negative 2. You can check that by going backwards. You distribute this negative to the 6 and this to the negative 2, and you'll get negative 6x plus 2. So let's go ahead and continue, because now we have common factor for each term. So we can pull out this common factor, and we'll get 7x minus 2, 3x minus 1. So 7x minus 2 times 3x minus 1. Okay, so we can double check this by just distributing. So 7x minus 2 times 3x minus 1. So we'll have 3x times 7x will give us 21x squared minus 7x minus 6x plus 2. Once again, we're on the right track because that's the same as this. So we'll have 21x squared minus 13x plus 2. And that is the same thing that we were given, so we're pretty sure we did it right. So that's going to be our final answer for this particular example. Alright, that concludes the long and tedious 6.4. I think ultimately the only video that's really absolutely necessary to watch for 6.4 is the I can't remember what the number for it was now. I want to say it was 6.2.2. I think the one where I gave the faster example of how to factor by guess and check. That's probably the only one that's absolutely necessary. This factor by grouping is kind of interesting, and if you prefer to do it that way, then that's great. But it can be a little bit more tedious, a little bit more difficult, and it's certainly the most difficult one to understand. So I will see you in 6.5. I don't believe we skipped 6.5, so I think we'll see you in 6.5.